All right, let's look at just first example here. Okay, so all we're going to be doing in these problems, at least today, is looking at different expressions and using algebraic strategies to change those expressions, to manipulate those expressions, to simplify those expressions. And so, things that you did in the skill builders and, in Algebra 2 and things like that, we did things like, factoring, that was factoring out a term or factoring a trinomial or things like that. Just multiplying, polynomials together. Or multiplying terms together, combining like terms. Combining the like terms of an expression. Or, adding or subtracting fractions, right? Things that you've done in algebra and just in math all the time that you've been building up those skills with. And changing the way that expressions look, right? That's a big part of algebra, is just changing the way something looks, its form. Another big one is just substitution. Okay, substitution, just this concept of if one value or one expression is equivalent to another one, then we can just substitute there and change it. So let's look at this first one. It says sine x times cosine squared x minus sine x. Okay, and all we're trying to do here is change this or manipulate it or simplify it in some way to make it look different. And since it says simplify, I'm hoping that this thing goes down into maybe a smaller expression. So what we're going to do here is, usually the first thing we do is look and see in this expression, is there some sort of substitution we can make that would be helpful, right? So I'm going to look up to my little identities here and maybe just see here if there's something that could be helpful that I could substitute. Okay. The first thing that I usually look for is these guys right here. If I can use a Pythagorean identity, that is a lot of simplification. Like if I have an addition like sine squared plus cosine squared and I see that in my problem, I know that's just equal to 1. Well, I'm going to use that right away because that just simplifies my problem down so quickly. I'm going to immediately use some of these things that I see here. There's really nothing I can use here in terms of Pythagorean identity. And I can look over here to see if I can make a substitution, but nothing really is going to help me here. You're going to see that in these problems, keeping my terms in terms of sine and cosine is often our best bet. So the only thing that we have to do here is we have to factor. We have to factor out the common factor, which is what we did a lot of in the skill builder if you've been doing that. So in this expression, you can see that this expression has a sine x that's in common. So what we're going to do here is, because it has a sine x, we're going to factor out that sine x, and we're going to pull it out, divide everything out. Let me write it like this. I'm going to divide out a sine x here and divide out a sine x here, divide both of them out, and then I'm going to factor it out here, like the reverse distributive property. And then I'm going to look at, all right, what's left over. If I look at this term and I divide out that sine, well, then I'm left with cosine squared x. So this becomes cosine squared x. And then I look over here and I have sine x divided by sine x. Well, that's equal to 1. So I say minus 1. So, okay, we factored it out, and hopefully this helps us. So now we're looking at, I really want to use a Pythagorean identity. Like, that is the best simplification that I can make. So now I'm looking at this right here. And this is a puzzle piece right here. I got cosine squared minus 1. So I'm going to look up, and this kind of looks like Pythagorean identity, maybe. I look up here, and is there a cosine squared x minus 1? So I'm looking over here for a cosine squared x minus 1. I do not see a cosine squared minus 1 anywhere in this problem. However, we can make one of those. Okay, so I don't see it right away, but this is a really, really important thing that you have to be able to do. So I don't see it right away here, but I do know that sine squared plus cosine squared is equal to 1. Okay, so I'm going to write off to the side here just to show you. Sine squared x plus cosine squared x equals 1. Okay, I know this to be true. Well, my question is, can I isolate, or can I make a cosine squared minus 1? And the answer is yes. I'm just using my algebra skills. I'm just kind of trying to solve a puzzle here. So try to think of these problems like that. So I want to make a cosine squared minus 1, and I know I can do that because I have this equation that's true. Well, I'm just going to subtract 1 here. If I subtract 1 from that side, then I'm going to have sine squared plus cosine squared minus 1 now equals 0. So I can clearly see that this puzzle piece right here, cosine squared minus 1, there it is. I just made it. Okay, I can make that substitution. Well, what do I want to do here? I want to solve for that yellow blob right there. I want to solve for the cosine squared minus 1. So I'm going to continue my algebra here and just do what I need to do to get this puzzle piece ready. I'm going to subtract sine squared to both sides. Okay, and then I'm going to be left with cosine squared x minus 1 would equal negative sine squared x. And now I've got the job done, right? Because I know that from this identity, sine squared plus cosine squared is equal to 1. Now I couldn't use this little puzzle piece directly and just make a substitution and call it a day and say, sweet, I couldn't just plug it right in there. It's kind of like if I have a puzzle piece and you're doing a little jigsaw puzzle, you think you have the right piece, but it doesn't fit until you move it, you turn it around, and then you try to make it fit, and you're like, okay, now it fits. This is the right puzzle piece right here, but we just had to change it around a little bit so it fit our current situation right there. Cosine squared minus 1, you can see, is equivalent to negative sine squared. So I'm going to make that substitution and just say, okay, this right here, I know that is the exact same thing as negative sine squared x. So I'm going to substitute. And now I have my problem down here. This is simplified now because, at least I consider it simplified, because now we just have signs in there, and there's actually no addition or subtraction. It's just sine x times negative sine squared x. Okay, so now I can just multiply these. If I have sine x times a sine x, or sine x times sine squared x, that would be like saying, well, what's y times y squared? And you'd be like, oh, exponent properties. That's got to be y cubed, right? Same thing here. Sine x times sine squared x is sine cubed x. Okay? And there's this negative factor here. I'm going to keep that negative. I'm going to put it outside here. So my answer here is negative sine cubed x. Okay? Or that's one of the several answers that we could have. This is our best one because it really is simplified. You've got to treat these problems, some people love them, some people just hate them, but you got to have the mindset of, I'm trying to just manipulate, do some algebra here. It's like a puzzle. It's like a crossword or a Sudoku or whatever. And you're trying to factor something out. You're trying to do a substitution. You're trying to change things around so you can simplify the problem down further and further. So it's going to challenge your algebra skills. And so that's the first one. And again, I'm going to warn you that some of these problems, especially day 2, you're going to have perseverance. You're going to have to go through these problems, and there might not be an exact 3-4 steps to follow to solve my problems. You have to maybe try things, and if they don't work, then you're going to try something else, and you're going to get better and better at them, but you won't start off as being good at them, of course, because you're just starting, right? So that would be the first one. This one simplifies down to negative sine cubed.